Okay, we are now going to look at more complicated trig equations. So let me zoom in a little bit. The first thing we're going to do is we're going to look at how you can solve some more complicated equations by factoring. This is kind of one of the main overall techniques. It's the first thing you try to do, okay, when you're doing trig equation, and if you can, then you're good. So what you're basically doing is by factoring, setting it equal to 0 and factoring, you're going to get simpler equations, basic trig equations that you can solve. So let me start with this one. This is a pretty straightforward one. What I'm going to do is I'm going to move everything to the left side so that it's all equal to 0. So I'm going to move the 5 sine x over here. Like that. Okay, so I'm setting it all equal to 0. And now you see I got a sine x in both terms, so I can factor that out. And by factoring, I now have these two factors equal to 0. And so what that means is either the sine of x has to equal 0 or 10 cosine x minus 5 has to equal 0. So you're setting each factor equal to 0. So this is very similar as when you're solving a quadratic equation or even a higher degree polynomial. You're factoring, it's all equal to 0, factoring it apart, setting each factor equal to 0. And the solution to these simpler equations will be a solution to the original equation. Okay, so the sine x equal to 0, that one's pretty straightforward. Here and here it's equal to 0, and so you can simplify this by just saying k times pi. So if k is 0, it would be that. Or k is 1, it would be that. K is 2 would be that. 3 is that. 4 is that. Same with the other way. So sine x equals 0 is simplified with that. Notice cosine x equals 0 would not be simplified with that, because you would have these 2 points. Okay. So this one here becomes cosine x equal to 10 cosine x equal to 5. Cosine x is equal to 5 over 10, and cosine x in would have to equal 1/2. And this one you can solve. So cosine x is equal to 1/2 up here, which is pi over 3, and down here, which would be 5 pi over 3. So the solutions here would be pi over 3 plus k times 2 pi and 5 pi over 3 plus k times 2 pi. And those would be the other solutions. So all three of these would be the solutions to the original equation. Okay, so the idea is bring things to all to one side so it's equal to 0, and then if you can factor apart, then you can solve the equation. So let's try this one. This one's a little different here. So I'm going to move this to the other side like before. So 4 cosine squared x times tangent x is, or minus 3 tangent x is equal to 0. Okay, so now what I can do is I can factor the tangent out. So I get tangent x times 4 cosine squared x minus 3 is equal to 0. Okay, And what I'm left with here is actually an expression that I can factor. And I'm going to use, this is like the sum and difference of a binomial. So I'm basically using that a squared minus b squared is equal to a plus b, a minus b. Okay, I'm using that there. So this would be tangent of x. And then I could write this as 2 cosine x plus the square root of 3, 2 cosine x minus the square root of 3, all equal to 0. Okay, so that factors up like this, and so you either get tangent x is equal to 0, and then these here, just to save room, what I would be doing for this one is I'd bring the square root of 3 to the other side, dividing by 2. So this one is really cosine x is equal to negative square root of 3 over 2. And this one would be cosine x is equal to positive square root of 3 over 2. So this one is the negative there. Okay? So then you have these three. So the tangent x equals 0 at 0 plus all the rotations of pi. So this could actually be simplified down into just k pi. Okay, now this one here, negative square root of 3 over 2 would be like, oops, not on the y-axis. I do that a lot. It would be on the x-axis here, like this. This would be like negative square root of 3 over 2. And you'd get one up here and one down here. And that's like the pi over 6. Okay, and then this one over here would be like, the one down here would be like 11 pi over 6. And that's kind of hard to see, so maybe I can zoom in on this equation now. And so what I get is, for this one, x is equal to pi over 6 plus k times 2 pi, and x is equal to 11 pi over 6 plus k times 2 pi. And this one is the negative, right? So if I did a unit circle over here, it would be like negative square root of 3 over 2, and you get this one and this one. And this would be 5 pi over 6 and 7 pi over 6. So I'd also get the solution x is equal to 5 pi over 6 plus k times 2 pi. X is equal to 7 pi over 6 plus k times 2 pi. And then I could move that down. X is equal to k pi. And then I could circle all of those. And those are the solutions to the original equation. Okay, so that's the idea behind factoring. You factor it apart, set each factor equal to 0. And so then, in the end, ultimately you're solving the basic trig equation. And it's going to, as what you're going to see, it'll always end up as a basic trig equation, or it could end up as a multiple angle. And we'll see that. But it'll always end up as one of those two. Okay, and of course these had all nice numbers. They were special points on the unit circle. These equations won't necessarily be special points on the unit circle, but you can still solve them. So that is the first thing. Next lesson we'll look at solving equations of the quadratic type.